Taji, we are doing question number 21. Question number 21 is basically, question number 21 is a train travels from one station to the next. It starts from rest at time 0, accelerates uniformly for the first 20 seconds. At 20 seconds, it reaches top speed of 25. It then travels at this speed for further 30 seconds before decelerating uniformly to rest. The total time for the journey is 60 seconds. Sketch means the label or values are not needed. So sketch a speed time graph for the motion of the train. Do not use graph paper. Put the speed of the train on the y-axis and time along the x-axis. So for the motion of the train, we have to draw a graph. Let's try that. This is part A, first part, A part 1. So they want us to draw a graph of speed of the train against time. Initially, the train accelerates for how much time? The train accelerates uniformly for first 20 seconds and reaches a speed of 25 meter per second. So in 20 seconds, it reaches a speed of 25 meter per second after accelerating at a uniform rate. So up to 20 seconds, we are having a uniform acceleration, so a straight line. This straight line shows that the train has a uniform acceleration. Then they are saying that this 25 meter per second is highest speed, and for further 30 seconds, it travels for at this speed for further 30 seconds. So 20 plus 30, it's 50. So from 20 to 50 for a further 30 seconds, the car maintains this speed. Now the car stops at 60 seconds after decelerating uniformly. So they said it decelerates uniformly to come to rest in a total time of 60 seconds. So from 50 to 60 next 10 seconds, the car comes to rest by decelerating uniformly. It's a straight line graph because it's a uniform deceleration. Now this is the graph of speed versus time. Now the second part of the question is write down a word equation that relates acceleration, time, and change of velocity. They want a word equation for acceleration. So you'll write acceleration is equal to change of velocity over time for change, or you can say it's time. So change of velocity, if it is divided by time, it will be the acceleration. Now the third part of the question. Third part is explain what is meant by uniform acceleration. Uniform acceleration means uniform acceleration uniform acceleration means that the velocity changes equally in equal intervals of time. So uniform acceleration means a change of velocity that is same in every interval of time, in same intervals of times. Use your graph to calculate the deceleration of the train as it comes to rest. Deceleration or acceleration is slope of speed time graph. So in the fourth part, we can calculate the slope, and the slope will be the deceleration. Here we have 50 and 25, and here we have 60 and 0. So if we calculate the slope, it will be 0 minus 25 over 60 minus 50. So it will become minus 25 over 10. So it will be minus 2.5 meter per second square. So the deceleration is minus 2.5 meter per second square. Now, if we say deceleration, then negative sign is not needed. Deceleration of 2.5 meter per second square. This is the final deceleration. Now, the next part of the question. Several forces act on the train when it is moving. When the train is moving, there are several forces that are acting on the train. Name the horizontal and vertical forces that act on the train and give the direction of each force. So the first part of the B part is name the horizontal and the vertical forces which are acting on the train. So B part 1, it's B part 1. It is on the train, label the horizontal and the vertical forces. The horizontal force on the train will be, first of all, in the direction of motion, we have driving force. In the direction of motion, we have driving force. Against the motion, we have friction, as well as friction between the wheels and the ground. And also against the motion, we have air resistance. So we have three horizontal forces. We have three horizontal forces, and they are driving force in the direction of motion, driving force in the direction of motion. Then we have air resistance and road friction or friction with the surface, because train is not running on the road, obviously. So we should say friction with the surface, air resistance and friction between the wheels and surface is against the motion. So the force that is in the direction of motion is the driving force, and the friction with the surface and air resistance is against the motion. Now, vertical forces, there are two vertical forces. Vertical forces are weight of the train and reaction forces on the wheel that could be represented as overall reaction force. However, these reaction forces will be on the wheels individually. Actually, they are R1, R2, R3, R4, and it is on each wheel. Now, when we add them all, it is the total reaction force. So, reaction forces are acting on the wheels, which can be added together to make the overall reaction force. So, vertical forces are vertical forces on the train are weight of the train is downwards, weight of the train is obviously weight of the train is downwards, and normal normal reaction normal reaction force is upwards. Weight of the train is acting downwards, while normal reaction force, there is actually there is not a single normal reaction force. Every wheel has normal reaction force, and we can add all of them. Now the next part is explain whether the horizontal forces are balanced or unbalanced when the train accelerates. Acha, we'll go step by step. So when the train accelerates, we have to comment on the horizontal forces. Number one, when train accelerates, when train accelerates, obviously they are unbalanced. Obviously they are unbalanced. They are unbalanced as the net force is there in the direction of motion. So if there is a net force in the direction of motion, then obviously the horizontal forces are unbalanced. Horizontal forces are not balanced because we're getting a resultant force in the direction of motion. The second one is when the train travels at a constant speed. So when the train is traveling at constant speed, what do you think about the horizontal forces? Balanced, since the train is moving in straight line, balanced as no change of speed, and they already told that the train is moving in straight line, so no change of speed or direction. They already told that the train is moving in straight line, so the direction is not changing. The next one, when the train decelerates. When the train decelerates, the net force is opposite to the motion. When the train is decelerating, the net force will be opposite to the motion, hence unbalanced. The forces are unbalanced because the net force is opposite to the motion when the train is decelerating. Achha, the next part is you may draw to help your explanations. We already explained everything. Achha, C part, a second train has non-uniform acceleration. Sketch a speed time graph showing a non-uniform acceleration. Do not use a graph paper. Uh, they randomly said that there is an other train and that train has a non-uniform acceleration throughout. So possible answers could be speed time graph for a non-uniform acceleration can be the acceleration could be increasing or decreasing. In both ways, it will be correct. So you have two possible answers for this question. For part C, basically you have to represent a train that is moving with a non-uniform acceleration. Non-uniform could be increasing or decreasing. So it can be an increasing acceleration or it can be a decreasing acceleration. Both possibilities are there. If it's increasing acceleration, we have this graph. If it's decreasing acceleration, it's this graph. Both graphs are equally correct. We are doing question number 21. So we are done with question number 21 now. Now we'll start the next question.